Alright, hello and welcome to my video on factoring quadratic functions. This is just an introductory video, and so what that entails is we're just going to be working with answers that are whole numbers. And so if you're looking for something a little more advanced than that, or if you're looking for a way of looking at it in terms of geometry using visualization, then what you want to do is go to the end of my video and I've got links to things like that. Okay, so if you're still with me, if that sounds like what you want, I've got good news. So if you know how to factor whole numbers, then you know how to factor quadratics. So let's go ahead and think to start with about factoring 12. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So if that came pretty easily to you, then so should this. So first, let's just talk about the technique. All right, what do? Well, we just look for factors of 12. Hey, we've seen that before, haven't we? Right there. All right, so those factors are 1 and 12, 2 and 6, and 3 and 4. And the next of those, we have to check, do any of them add up to 7? Well, 1 plus 12 is 13. 2 plus 6 is 8. Oh, there's our key. 3 and 4 add up to 7, our middle coefficient. It's exactly what we want. That tells us that our answer is x plus 4 times x plus 3. All right, now let's think a moment just about why that technique worked. All right, so if you're familiar with multiplying linear equations like these are, x plus 4 is a linear equation, so is x plus 3, then you'll know that each term in the first equation multiplies by each term in the second equation. Okay, so that ends up being, well, our answer. But let's look at why more generally. Okay, let's look at how we get our constant. Well, we multiply our two constants. Remember, those are the ones we had to figure out. And see, when you multiply these together, they get 12. So now we see, to get the constant to end up right, we needed them to be factors of 12. All right, but what about our middle term, our x term? How did we end up having that work out right? Okay, so we notice that each x term is going to multiply by the other constant. And so that's going to get us 4 times x and 3 times x. In other words, we've got both our constants multiplied by x. So if those constants add up to 7, then that means that the middle term should add up to 7x. 4x plus 3x is 7x. And then our first term is, in this case, sort of a gimme. So x times x, it's always going to be x squared. Now, as mathematical thinkers, we know that there's sort of a hidden, it's sort of like there's a hidden 1 in front of both of those x's. Now, that won't always be the case, but once again, this is a beginner video. But if you'd like to see the extension of this method, that once you've learned this method, really is just basically adding one more step, then you'll want to look at the AC video on the AC method at the end of this. And that will tell you how to use almost this exact same method, but when your lead coefficient is not 1. Okay, so I mean, that's it. You basically understand it. But I would like to go ahead and talk about a few examples who also, for simplicity's sake, work with factors of 12, but for their own reasons are maybe a little bit trickier than this one is. Okay, first, let's look at x squared minus 13x plus 12. So once again, same factors, but now we're adding up to a negative number. So these numbers here, well, they're no longer really going to do us much good, are they? Because they're going to add up to a positive number. But something like negative 1 and negative 12, well, when you multiply those together, they're still 12. So those are also sets of factors, but they're going to add up to a negative number. For example, negative 1 and negative 12 are going to add up to negative 13. So, bam, we have our answer. Same thinking. All right, so what if the last number is negative? So we'd have to find the factors of negative 12. Okay, so in this case, it's going to alternate. One of our numbers is going to be negative. Okay, so 1 times negative 12, that's negative 12. We can see the pattern here. All right, so now we just have to check, all right, which one adds up to -4? And so there are certain shortcuts we can use, such as we can think to ourselves, well, we don't need to check the times when the positive number is bigger. So that just gives us 3 options. So 1 plus -12 is -11. Okay, that's not it. 2 and -6 is going to be -4. So that must be our answer. X plus 2 times x minus 6. Now, as you get more proficient at this, or maybe if you're already proficient in doing factoring, you won't necessarily have to write out that table. You might be able to do them in your head, and maybe even add them in your head. You know, keep in mind that you might still have to show your work depending on what the teacher is trying to do for you and help you to learn, because explaining your reasoning becomes a more and more important part of math as you go along. All right. Now, so as I mentioned before, it gets a little more challenging if you have a number other than 1 as your lead coefficient. For example, here we have 2. Now this is actually pretty convenient because each of those whole numbers is divisible by 2. So we're actually able to once again utilize our whole number factorization skills and divide all of these by 2. So that actually has us end up with a problem we've already solved. In fact, the first problem we solved. So if we think back to that work and how we did it, we got 2 times x plus 4 times x plus 3. Okay, wonderful. So that pretty much spans what the sort of problems that this technique is useful for. So I'll just real quickly show you one of the limitations of this technique. And I mentioned it already. And that is when you've got a lead coefficient of something other than 1, and that coefficient isn't divisible, everything isn't divisible by the same number. So everything is not divisible by 3. And so I'll give you a quick preview of what we'll be doing next, and that is solving this one using the AC method. And you're free to click this now if you want to go straight there. So each quadratic is going to be of this form, ax squared plus bx plus c. So in our new technique, one of the main differences is instead of finding the factor of c like we were before, remember when this was always 12, we're finding the factor of a times c, which in this case, well, how convenient, is also 12. And once again, we'll be finding numbers that add up to it. But as I was mentioning before, it turns out that there is going to be 1 or 2 extra steps that are actually not too challenging. But the same sort of mathematical thinking at the root of it is the same. Okay. So what else do we have for you? Well, we've got advanced techniques. So this includes the AC method we talked about before. And then it includes methods that talk about more than just whole numbers or integers. We're going to be talking about solutions that actually end up being fractions, or in other words, rational numbers. And then we'll have the next technique, which is techniques that involve taking the square root. So an example of that is x squared minus 2. That's something that can be factored, but maybe a little bit surprisingly, you can't do that with integers or whole numbers. And then finally, we'll be able to extend this to finding a root, not a root, but a factoring of any quadratic. But in order to do that, we not only have to use all the real numbers, but we also have to use complex numbers. Okay, and then of course, there's a shortcut that you sort of get through doing the completing the square technique called the quadratic formula. And we'll be going over how to use that to get to do our factoring. It's sort of like sometimes you like using a cannon to destroy a mouse, but it can be very useful. And then of course we've got a video on the geometric interpretation. If you feel like you're a geometric learner and you're not in the mood to learn a technique instantly, if you've got some time on your hands, or if you just want to look at a way of adding some meaning to your understanding of factoring, I highly suggest you check that out. Thanks again for watching my video, and have a great day.